Well, let's look at this last conversion problem that's here on our handout. It says a patient was given 35 milliliters of Indocin. All right, so the patient received 35, add 5 there. The patient received 35 milliliters of Indocin. The label states that 5 milliliters contain 50 milligrams of the drug. All right, so as far as the pure drug in these milliliters of liquid, there are 50 milligrams of the pure drug in every 5 milliliters of the liquid. So Indocin must be one of those drugs that you take the solid form and you dissolve it in some sort of liquid, and then it's the liquid that is administered. And in this case, there are 50 milligrams of the pure drug in every 5 milliliters of the solution. The question we had then was, how many grams of Indocin did the patient receive? So we want to know how many grams of the pure drug did the patient receive. They received a liquid. We want to know how much solid pure drug did they receive. So we need to get from milliliters to grams. Well, this equivalence can get us from milliliters to milligrams, and then we can get from milligrams to grams. Oh, this is an interesting problem. We're staying all within the metric system, aren't we? Milliliters, milligrams, grams are all measurements in the metric system. We're not moving outside of the metric system to the household system. We're staying completely confined in the metric system of measurement. So we want to get rid of milliliters. We want to get rid of the liquid measurement, and we want to get to solid measurement, milligrams. And it says 5 milliliters contains 50 milligrams of the drug. So now we would know how many milligrams of the drug, if we did this arithmetic, we would know how many milligrams of the pure drug the patient received. But we want to know how many grams that was. So we've got to get from milligrams to grams. And do you remember that relationship? That 1,000 milligrams is the same amount of solid as 1 gram. So we can use this relationship, this equivalence, to get us from milligrams to grams. So we want milligrams to go away. We want grams to remain. So we can cancel milligrams by putting it in the denominator. That would be 1,000 and 1 gram. Well, let's see what we could do to make life a little easier for us in terms of our arithmetic. 5 goes into 50 10 times. And 35 times 10 is 350. Or how about this? 10 goes into 10 one time. 10 goes into 1,000 100 times. So we have 35 over 100. But remember, this is the metric system, so we want to represent our answer as a decimal. Well, that's 35 hundredths, isn't it? And isn't this 35 hundredths when written as a decimal? Remember, to go from a decimal to a fraction, you write what you read. You read that 35 hundredths. That's 35 hundredths. So we could actually go the opposite direction as well. 35 hundredths as a fraction is 0.35, 35 hundredths as a decimal. So if the patient was given 35 milliliters of the liquid drug, they actually received 35 hundredths grams of the pure drug.